All right. Without further ado, our topic of today is your next favorite programming language, Gleam. It is presented by Dillon Mulroy. Dillon is a software engineer with a decade of experience working in JavaScript and TypeScript ecosystem. He has worked on notable open source projects like Victory Charts and spent a better part of 6 years consulting, including Formidable, a leader in ecosystem. He has recently begun exploring OCaml, ReasonML, and type systems. Dillon can regularly be found streaming his work on Twitch with OCaml, Gleam, and Coffee. Thank you for joining again, Dillon.
Yeah. Thank you for having me. Already given a great introduction, but my name is Dillon Mulroy. I'm a software engineer at Vercel. I started at Vercel almost a year ago now. I am the lead and product owner of our domains product. So if you have any questions or complaints or feature requests for domains on Vercel, I'm your guy. You can find me streaming Monday through Friday on Twitch. Generally, I've been doing more TypeScript stuff, working on some freelance work in the mornings, but I stream from, I aim for 7-ish a.m., don't always make it, to 10 a.m. So if that's your thing, tune in. You can find me shitposting and yapping on Twitter always. I have some open source and a bunch of code on GitHub if that's your jam, and then a link to like all my resources, previous conference talks, slide decks, all that is on my personal website at dillonis.online. Okay, so back to programming languages. We're kind of like in this golden age of programming languages right now. We've never had it better. We've never had more choices. The new languages we're seeing kind of crop up and grow into maturity are taking the best features and ideas from those that came before them. And they're also adding features and capabilities from cutting edge PhD programming language research. On top of that, older languages are evolving and modernizing to add these capabilities as well. So what are some of these features and capabilities? Well, up first is linear and affine types. What these are essentially, it's the type system that's going to be powering essentially Rust's borrow checker. It's going to give us confidence in the type system that values at compilation time are only used one or n number of times, and they're scoped appropriately to memory or even code regions. Another one is algebraic effects. You see this cropping up kind of in mainstream languages, as we were kind of talking about before this. You'll see a lot of algebraic effects in Haskell. OCaml just recently added algebraic effects to power its multi-core concurrency model. There's a language called Coca, which is kind of doing a lot of that kind of PhD level research into algebraic effects. And in fact, if anyone is familiar and writing React, the way that suspense works is kind of similar to algebraic effects. Like I like to call the suspense API a poor man's implementation of algebraic effects. Essentially, under the cover, the way suspense works is when you have some asynchronous piece of work that you don't want to block on but resume to, rather than throwing an error, what the code does under the covers is it throws a promise, and then somewhere up the component hierarchy, you have your suspense boundary, which is, for simplicity's sake, looks like a try catch, and it catches and checks if it's a promise that was thrown rather than an error, and it will sit there, and when that promise resolves, it will resume your code further down the stack. So that's kind of a easy way to reason about like what algebraic effects are, kind of like resumable code. We also have gradual type systems, right? Gradual type systems are going to be seen in languages like TypeScript. You can start with a plain JavaScript code base, and you can slowly tack on types over time. You can have part of your code base still be completely dynamic and untyped. You can have, maybe an entire code base that is strictly typed, or maybe you need escape hatches here and there. We also see this cropping up with Elixir, right? They're getting their theoretic types. That is a gradual type system. Maybe there are things for Python and Ruby, I can't recall, but we see this cropping up more and more. Then we have things like algebraic data types, or specifically sum types. These are going to be what are called enums in Rust, and they basically just let you kind of more declaratively describe your data models. And hand in hand with algebraic data types is pattern matching. If you've worked in a language with pattern matching, it's really hard to go back to a language that doesn't have it. Then immutable or persistent data structures. These are found commonly in functional programming languages, most famously in Clojure. They have a bunch of persistent data structures, and what these are they essentially let you do mutations on these immutable data structures and under the covers, rather than doing full copies and new allocations. It does this thing called structural sharing, where only small bits get replaced and the rest of the structure is shared. So it makes working on, in kind of these pure or sound ways more safe and more performant. And then we also have things like actor-based concurrency models. This is going to be concurrency models that you see in languages like Elixir, Erlang. If you've ever worked in Java or Scala with the Akka framework, they use an actor-based model. You can emulate actor-based concurrency with Go. So we've never had it better, and we've never had more choices, right? Choices. We have so many choices. How do we even begin to make sense of these choices, right? We have TypeScript, we have Go, Java, Elixir, Haskell, PHP, Swift, Rust, Kotlin, Ruby, Python, Rock, Zig, OCaml, Dart, C, C++, C#, F#, right? It's dizzying, super dizzying. There's so many choices. So I want to talk kind of about my language journey, how I got to where I'm at, why I wanted to give this presentation. So let's jump in. Right. My language journey, a timeline, and my takeaways. So my first job was at State Farm technically started in 2013 as kind of a half-time or part-time intern, but I got thrown into the deep end and was writing enterprise Java. And I was specifically, the first team I was on at State Farm, I was writing Java 1.5 and struts. So, not the most enjoyable experience. From there, I kind of moved on to a team where I was writing a little bit more modern Java, that being 1.7, huge jump at the time when I think 1.8 was out. But at that point, I had got to use Spring 3.0. And my CS education wasn't super strong. I went to a small liberal arts university in Pennsylvania with a really weak CS program. So I learned Java a little bit, but I didn't really learn. So during my time at State Farm, I got thrown into the deep end of what development looks like in the real world. And even being that green or that junior of a developer, I kind of had some takeaways that I always felt that Java was overly verbose, right? There's tons of syntax, especially when you get into generic programming with Java, it gets really, I don't know, you get a lot of syntax to do simple things, and books like the Gang of Four book, and all the dogmatic design patterns that go along with it just exacerbate that problem. But on the other hand, I found it incredible working with tools like Maven and Gradle. Even though I now have experience with many different languages and ecosystems, and I think there are much better tools out there than Maven and Gradle. They're amazing for what they do and the complexity that they encompass and perform on behalf of the user. I also learned to value just how mature the Java ecosystem is, right? We were talking before the recording started on why it's painful to use languages like Haskell or OCaml, and that being the ecosystems are kind of Spartan and you kind of have to build everything yourself. With Java, it's either baked into the standard library or there is a battle-tested package that has probably been running in production for 20 years across every enterprise in the world. So up next, similarly, still at State Farm, I also got to experience JavaScript, and I fell in love with JavaScript. Now, bear in mind that up until this point, really my only, I dabbled with JavaScript and some Lua back in high school, but nothing really to solidify the concepts behind it. So I started writing JavaScript for a Spa app that sat in front of that Spring Boot, or it wasn't Spring Boot at the time, just a Spring app. And it was just so refreshing to use JavaScript. I could just drop into my project, I could write code. I didn't have to worry about these verbose types. I didn't have to worry about all this build tooling, right? We still had things cropping up at the time. And this also kind of colored my experience was NPM in this time period, right around 2014, 2015, that window of time, NPM was growing and getting popular. Node was coming to the scene. Browserify and Webpack and Gulp and all these tools that just almost focused on developer experience as the top priority. And that's kind of funny looking back, thinking that Webpack had a good developer experience. But at the time, compared to what we had, Webpack was amazing. So getting these tools that were just simple to use and made you productive super quickly in JavaScript and not having to worry about these types and deploying jar files and blah, blah, blah. It was just incredibly refreshing to me. Up next, I had left State Farm and I went to a defense contractor outside of DC. And I got to do a little 6 to 8 month project in Elixir. And this was my first real taste of functional programming. And I was too junior or green at the time to really like understand what functional programming was, or like what features of Elixir like kind of made it functional. But the real value that I took away from working in Elixir on this project, and the project was, you can think of it, there was a suite of front-end applications, 8 different UI applications, all owned by different teams. And each of these applications had like a different view of kind of the same data. And the service I built in Elixir was like this caching service that was driven with WebSockets. So all the front ends would connect to this little microservice, and it would pass through, try to hit Redis to get data. And then if it was a cache miss, or we implemented kind of like a stale while revalidate pattern, it would fall through and then fan out to like 8 different data stores and enrich the data and come back. So like really small constrained, but like concurrency and handling multiple connections and multiple clients was super important. And Elixir is amazing for this. Elixir's concurrency model, which is like built on top of Erlang, just makes it so simple. And this is kind of what the earlier slide talking about the actor model was getting at. Like, you just don't have to think about concurrency. Like, you very seldomly have to worry about things like mutexes or semaphores, because it does message passing with the actor model. So just having like these super simple primitives baked in for concurrency, like, just, I don't know. I fell in love with Elixir, even though I was still relatively junior at the time. Moving forward, at the same company, I also got to write Go. Now, up until this point, my only perception of types was Java. I've never written C++. I never worked in another language with types. Like, my perception of what it meant to be a typed language or a statically typed language was Java. I thought if a language has types, it's going to look and feel like Java. Now, Go is a structurally and duck typed language. They use very minimal syntax to achieve type safety. And it's just much more pleasant to work in, at least in my opinion, than Java. Go, working on this Go project also taught me, again, it reinforced my belief in having really good baked in concurrency primitives to the language, right? Like in Go, we have Go routines, we have channels, we have read-write locks, we have all these things that make it just a first-class citizen and super easy to do. Now, there's certainly more foot guns in Go when it comes to concurrency, but like, it's still baked in and there to take advantage of in an easy way, and tons of resources for it. And maybe the most important thing that I took away from writing Go was treating errors as values. Now, Elixir does this, but I honestly can't recall ever thinking about this problem when I was writing Elixir, but I remember it becoming crystal clear to me after having been, at this point, working in JavaScript for, I don't know, 3 or 4 years professionally. Treating errors as value in Go, like, blew my mind. Like, people love to shitpost on Twitter that like every other line is like, if error does not equal nil, do next thing, right? But like, even though that's verbose, like, it faces the reality of software, that it's error prone and mistakes and exceptions happen, and that we shouldn't just focus on the happy path. And so like, despite the, verbosity of having to do all those checks, like, some of the most reliable software I've ever written was in Go, because it forces you to consider the unhappy path. Next up was TypeScript. Around this time, I had switched companies to go work at Formidable Labs. Formidable, back in like the 2016 to like 2021 era, they were basically speaking at like every JavaScript conference. A good portion of the React Native team worked there. A bunch of the early GraphQL creators were there. Like, I really got to cut my teeth and become a deep expert in TypeScript at this job. And around the same time, I started learning TypeScript. I had like avoided learning TypeScript up to this point. And I'm kind of glad I did, because like, between that window of learning JavaScript and learning TypeScript, like, there was this battle kind of going on between like Flow and TypeScript. And you had some like ReasonML people coming in from the side, and it's like, which one of these should I invest in? Should I start a new project with this? And like, I kind of got lucky by just waiting and not using types in JS until around 2020, or I guess maybe closer to 2019. But once I started using TypeScript, it was like night and day, right? Like, I had this experience a little bit in Go, like I mentioned, like having to treat errors as values and having that contrasted with JavaScript, where like, I don't know, maybe this function throws, I have no idea. And just starting to type application code and get type safety and get better tooling from the type system, right? That's what TypeScript was originally made from, was to make better dev tooling for JS devs. It just reinforced itself over and over again as I was consulting at various clients. Time and time again, we would get dropped into a company that was either looking to rewrite to TypeScript or already on TypeScript. And I just saw across apps of different scales, whether that's at, you know, a 5-person startup, Fortune 500, or Google, just the benefits of having static types and being certain of the data you're dealing with. Now, TypeScript's type system is not perfect by any means, similar to Go, actually, but there's a lot of escape hatches, but it's worlds better than a dynamically typed language as far as application safety goes. Up next is Lua, which I use Neovin, by the way. I maintain 2 relatively popular Neovin plugins for working with TypeScript. And again, much like Go, Lua taught me the value of having a simple, small, and opinionated language, right? I should have mentioned about Go, like one of the other beautiful things about Go is just how amazing its standard library is. Like when I was writing Go full-time, I very rarely had to reach for third-party dependencies because it was just there in the standard library. Lua is similar, maybe not so much as having a rich standard library, but it's small and opinionated. They use one data structure for pretty much everything. They call it tables. They use tables for arrays. They use tables for dictionaries or hash maps. They don't even have regex implemented in the language because it would increase the runtime too much. So being able to configure my editor with Lua is super nice because you can just drop in and do it. Like there's not a lot to learn. Like you can be productive within an hour if you've had programming experience prior. And I love that about Lua. Next up, and probably the most formative step in my programming language journey, was learning OCaml. I had taken a job now 2.5 years ago, 2 years ago, working at a company called Scalum, which was a institutional DeFi company. And I got hired as basically the lead front-end dev. I was going to be leading basically all TypeScript and React work. Now, I've been a full stack dev genuinely my whole career. And that wasn't going to stop at Scalum. But if I wanted to contribute in a full stack way, it necessitated me learning OCaml. Everything besides the client-facing app at Scalum was in OCaml. Our admin UI app was written in OCaml and compiled to JavaScript. We had a Excel plugin that was also in OCaml. All of our backend services were on OCaml. And you know, again, we were talking about functional programming and OCaml and F# and Haskell and all that before the recording started, but like genuinely learning OCaml had such a positive impact on me as a developer. It just fundamentally changed the way I think about problems, the way I tackle problems. It taught me really what functional programming means and how it can be practical and not just like, it doesn't have to be this whole experience of, monads and functors and, folding and applicative functors and blah, blah, blah. Like you can dive in and be productive and get the benefits of functional programming without all the academic jargon. And again, this is where, again, errors as values, you're gonna hear me talk about this a lot throughout this presentation, but like OCaml uses a result type. Effectively, like if you're not familiar with the result type, it is a kind of like an enum where you can have either a OK value or an error value, and it essentially forces you, much like Go, to deal with the unhappy or error path rather than just putting blinders on and focusing on the happy path. And finally, earlier this year, I started diving into Rust. Now, I've never written a lick of C or C++, never really done any system stuff, but I had a really, I think I had a more positive experience learning Rust than I think most people coming to the language. Despite that, because I had written OCaml prior to this, Rust was originally written in OCaml, and a lot of the features in the type system are inspired by OCaml. So yeah, kind of just fell in love with Rust as well. So where does that leave me today? Well, to be blunt, I'm still kind of unsatisfied. There are so many languages that get really close to being perfect or ideal, yet they fall short, right? If I'm thinking about what I love about concurrency, like I'm thinking about Elixir and Erlang, but those are both dynamically typed languages, and I've learned to value in the production software I build that types are beneficial. But if I go and look at like something like TypeScript or Go, like the type system isn't sound. And we'll get into what a sound type system means, but like long story short, it kind of means your type system can lie to you. Rust, right? Rust is kind of hard to onboard new developers to. Like each of these languages that I have experience in all have traits that have contributed to what I think help make sound and quality production software that I feel good about deploying and giving to my users. But they're each missing something that I have to give up, right? So what features would my ideal language have? Well, as you may have guessed it, it would have a sound type system, hopefully inspired by Hindley-Milner. So what is Hindley-Milner? Hindley-Milner is the type system or an algorithm that powers languages like Haskell, OCaml, Rust, and Swift. It basically works by building up a system of equations from your code and solving like the constraints of it at compile time, and basically guaranteeing you perfectly sound type safety. And one of the beautiful things about this is that in an HM type system, or in certain implementations of Hindley-Milner type systems, you can get away with essentially like annotating close to none of your types, and you will still have bulletproof 100% sound types. Which kind of goes into my first point. Like, I want a type system that works for you instead of against you. Like when you're writing TypeScript specifically, or even like Java, and you get into like the Gang of Four design pattern world, like it gets to be a nightmare and a slog and a ton of time. Like in TypeScript, if you get into deeply generic or dynamic code that you have to type, you're ending up with these type mappers and these nested ternaries to resolve types. And it just like, if you don't have the muscles built already from working with that kind of those kind of types on a day-to-day basis, like it can take a lot of time to work through and get the type, ironed down to be actually type safe. Likewise, I want a type system that gives me static typing safety, but the experience of authoring dynamic typing. And that's what HM type systems do. Because you don't have to annotate code, it feels like you're writing like plain JavaScript or Elixir or Ruby or Python, but behind the scenes, the type checking algorithm is doing all the work for you and staying out of your way. If you've written languages like Rust or OCaml, you'll know that if it compiles, it runs. Now, this doesn't, of course, get you out of the world of logic bugs, but it will get you out of the world of runtime type errors. I want simple polymorphism and generic programming. And with type systems like this, we get really powerful compile time optimizations to help with performance. So as I've been harping on, I also want errors as values. And more specifically, I want to throw try catch in the garbage. I had a hot take on TypeScript and JavaScript in specifically. Talked about this a little bit already, but my hot take is that JavaScript has the lowest bar of entry to building and being productive, which is a good thing, but one of the highest bars of any language and stack to building high quality, stable, and reliable software. Very few devs have the expertise to pull off the ladder. Now, I've been super fortunate of having been able to work at Formidable and now at Vercel. I've gotten to work and do work with some of the best TypeScript and JavaScript devs in the world. And we still make the mistakes of, just considering the happy path. And, we are not free from promise rejections paging us, at 2 or 3 in the morning. It's really, really hard to write really good quality backend services in TypeScript, or it's deceivingly hard, I would say. I would prefer to use a composable type like result, OK, and error, which you find in Elixir, Rust, OCaml, F#, all those languages, but I would be equally OK with a language having Go style where it returns a tuple of the OK and the error variant, or even a discriminated union where you have to check, some discriminator to get at the OK value first. Like we've been talking about, I want to enforce explicit handling of the unhappy path. Like, I don't want my code to compile and be able to run unless I've considered all the potential errors that can happen for my program, or I've explicitly said that an error should crash the process or program. I want to use strongly typed errors, and I want that feature because I want to distinguish errors between what I'll call expected errors and defects, which here I have called unexpected exceptions, right? TypeScript, if you do try catch, right, you'll know that the error that populates the catch clause is typed as unknown. that sucks. Like, I want to know the type of my error. I want to be able to let my caller decide what errors my code produces, what to do with the errors that my code produces, right? Like, maybe we're reading from a file system and a file not found error is a defect or an error that should crash a process. Jesus, can't talk. Crash a process in one person's code, but in another one, they have an explicit branch for handling that error. I want to avoid control flow interruptions. This is what throwing errors does, right? When you throw an error, it's going to bubble up and hopefully eventually get caught by a try catch. And along the way, it's going to basically collect the stack. I don't want that to happen. And all of this together, in my opinion, promotes more reliable, stable, and maintainable software. So I also want sum types and pattern matching. Sum types are essentially enums on steroids. And as I mentioned before, in Rust, sum types are actually called enums. Sum types let us encode meaning along with our data, right? It lets us, I don't know, be more declarative about the variance and invariance in our program. It allows us to express, model, and safely handle complex data structures and control flow with ease. You'll commonly see in languages with pattern matching, like this is actually what like made OCaml click for me. I was writing this little HTTP service for doing an OAuth flow, and I had a request come in that might or might not have a query parameter, and that was modeled using an option type. And I could pattern match on that option type. And when I pattern matched on it, I could explicitly match on the two different cases, right? You have some value being in the option or none, and it's just declared and laid out right there. So you can like see very easily like the different paths your program can take based on the data and types. Similarly to the first point, they help make illegal states unrepresentable, right? We want to do everything we can to help other developers using our code do the right thing. And by leaning on the type system and using some types, or even like in TypeScript, we call them branded types, we can make it as close to as impossible to have them do the right thing, right? Like rather than, let's say we have like a function that is like, I don't know, verify user or something that needs to take a user ID. Rather than taking in a string as a type, we should take in a user ID that has already been parsed and validated somewhere. And we can enforce that, hey, in order to call this code, you have to give me what we know to be a user ID. Exhaustive case analysis, right? So like if we have a switch statement or we pattern match on something, like I want the compiler to yell at me if I haven't handled every possible case. I also want first-class concurrency, and I want to embrace the actor model because it makes dealing with concurrency so simple. I ideally want lightweight, isolated units of computation. These are called actors, and I want them to be powered by green threads. Now, green threads are what power Go routines. They power Elixir and Erlang's processes. If you're familiar with Tokyo and Rust, those are green threads. And generally what like a green thread is under the covers is just like this lightweight, generally 4 kilobyte or less entity that is managed by a preemptive work scaling scheduler that manages all of the green threads in your program. And because of this and how cheap they are, as opposed to normal threads, you can spin off like hundreds of thousands or like 1 million of these things at one time and have all this concurrent stuff going on because the scheduler is so good and how lightweight the green threads are. I also want simple cross-process and type-safe communication via message passing. This is a feature of the actor model. Rather than sharing memory across green threads or actors, we're generally passing serializable messages. This lets us prevent, in a lot of cases, things like mutexes, read-write locks, or semaphores. I want fault tolerance through supervision hierarchies. And what this means is I want to basically model my program when I'm dealing with concurrency as a tree. At the top of the tree, we have our root process, and that root process will spin off child processes that run concurrently as actors. And those nodes will then spin off more processes, and each node in the tree is responsible for supervising the children under it. And you can essentially, in these supervision hierarchies, at any given node, say how you want to handle failure at that specific level. Should the children of this node, if one of the children crashes, should it restart? Should it restart 5 times? Should it not restart at all? Things like that. And I want to easily scale from a single core CPU to fully distributed systems without really having to think about anything. And As we talked about, this reduces the need for low-level synchronization primitives such as mutexes, semaphores, and read-write locks. Got ahead of myself there. Another super important thing to me is DX as a core value. And again, another callback to our discussion beforehand. This is where, unfortunately, I think languages like OCaml fall short. There's just not this focus on providing a great experience, a easy process of getting started. There's not a big ecosystem of packages to pull from. So I want my language to be simple, friendly, and opinionated, right? A lot of these came from my time writing Go and Lua. I want one obvious way to solve common problems. Like I don't want to have to sit and think about what design pattern out of the Gang of Four book to apply. I don't want to get caught up in thinking about all the varieties of ways of modeling the world in types in Haskell. Like I just want one way to solve the problem. And I want the docs to guide me there. I want the type system to guide me there. I want the standard library to guide me there. And again, I think Go does a stellar job at this. I also think it's really important to have a unified and modern toolchain. I essentially want one binary to do package management, building, formatting, docs, searching for packages. Like I want all of that in a single binary that's really well documented. It has a good, like auto completion. I also want my language to be approachable, have approachable, searchable, and thoughtful documentation. Two languages that I think get this right and do a really great job at this is Elixir. They have this documentation toolchain called HexDocs, and you can generate docs straight from your code with a single binary. Searching HexDocs is super, super simple and easy to do. There's tools for like searching for types in the Rust ecosystem, right? Cargo docs has kind of a very similar experience. And like, yeah, it just is such a game changer when the docs are good and the resistance to authoring and consuming docs is low. Like it just makes developing such a way better experience. Then I want friendly and informative error messages. One language that I think gets this really right that we haven't talked about is Elm. If you've ever written Elm, you'll know that the error messages are just like top notch. It's going to point exactly where in your code the error is. It's going to explain the code. It's going to give you context on what you could do to solve the code. It's going to link to docs. And it's going to do this all in a really, clear way. It's not going to be using confusing, verbose programming language or terminology, I should say. It's just great. I think Rust also has really great error messages, and Rust error messages were actually inspired by Elm. The nature of Rust error messages are kind of more complex just given the scope and purpose of Rust, but I still think Rust has a really good experience for error messages. I want fast compilation times, something Rust does not have. And I want the language to favor backwards compatibility, language simplicity over excessive flexibility and features. I also want to be able to code once and run it everywhere. I want to embrace versatile compilation targets. And I think you're starting to see this more with some of the more modern languages. Trying to think of a good example, like even OCaml, right? OCaml is an older language, but it's kind of embracing this idea, like we can compile OCaml to, native CPU targets. We can compile it to bytecode, and we can even compile it to JavaScript. Other languages are also compiling to WASM too nowadays. That's becoming more and more of a desired feature. But I want my ideal language would have support for compilation to JavaScript at a minimum, and a simple way of binding or using existing like NPM packages. I want to be able to share my types in my front-end code and my back-end code. I want good support for serverless and edge environments. I also want simple cross-platform support. And it would be a huge plus if my language had native and WASM targets. So as you may have guessed and given away earlier, I haven't been completely honest about my full language journey here. There is one more language here in this timeline, and that language is Gleam, which hopefully will be your next favorite programming language. I think if I had the choice today, we'll get into it, but I would enjoy using Gleam for just about everything, and we'll get into why. So what is Gleam? Gleam is described as a friendly language for building type-safe systems that scale. Gleam is a sibling language to Elixir and Erlang that runs on the Beam, which is Erlang's virtual machine. Gleam uses a simplified implementation of the type system found in Haskell and OCaml. And but wait, there's more. Thank you, Billy Mays. Gleam can even compile to JavaScript and generate TypeScript types in the form of .d.ts files. Gleam also isn't exactly just like a brand new language. It started work in 2016. Louis Pilfold's the creator. They started way back in 2016 where it looked more akin to Erlang with types. And over the years, they put more and more time and effort into it up to the point where we got Gleam version 1 last March. I don't necessarily think that GitHub stars is a great measure for really anything, but I do think that it says something that Gleam was one of the fastest growing projects on GitHub last year. It is very quickly got adoption and growth and became a beloved language by a lot of people, and people that didn't necessarily come from Erlang or Elixir. So what does Gleam look like? Well, I have a couple code samples from a project I worked on earlier last year called Glitch, which is a a half-implemented Twitch client that I never got around to finishing and joined the graveyard of projects on my GitHub. But this is kind of what it looks like, right? Here we're describing, or we're creating a what's called a record type in Gleam, and it's for a type user. So we say pub type user. We have inside of it user, which is a bit redundant, but you'll see why a little bit later. Then we have, a couple string fields. We have this broadcaster type, which references a type called broadcaster type, which isn't shown. We have profile image URL, which references a URI type. We have an email, which is a string option, and a created at timestamp. Now, I kind of want to focus in on this option type, right? We talked about options and results a little bit earlier, and this is kind of what parametric polymorphism or generics look like in Gleam. And in fact, this is the exact type definition from Gleam's standard library of the option type, right? So you'll commonly see in functional programming languages, the initial or first generic parameter in a type denoted as A. In languages like C# or TypeScript or Java, you'll typically see that as T, same thing. But here we're saying that this option type is generic over some type A, and it has two variants, right? This is an example of a sum type or an enum, right? So we can either have a sum variant, which carries data with it of type A, or we'll have the none variant, indicating essentially null or undefined, right? Generally, these languages like Gleam, Haskell, OCaml, Rust, they don't have the concept of undefined or null. They model that with the option type and use the none variant of the option type to deal with that. So here, let's look at the get users call to Twitch. Here we take a client, we take a get users request. We're annotating that this function is going to return a result that if it succeeds, will return a list of users, or if it fails, we'll get a Twitch error. And moving down this code, we create a request. We create a Helix request, which is just like Twitch's name for their API. They call it the Helix API. So we generate an empty or new Helix request. We pipe that into the API request module set query function. We derive query params from the request we got passed in a couple lines up. We pipe the result of that into setting the path on the request. The next line might look a little weird with that use keyword and the arrow. You can kind of read that as like, if you're familiar in the TypeScript world, as await. It's kind of doing the same thing. We're basically saying, hey, we're going to await the result of client.get. And if we get the OK variant, we are going to assign it to response. Or if we get an error, we're going to immediately return from the scope with a Twitch error. So assuming we get an OK response, we pull the list data from it and decode it with our JSON decoder and return it out. Now, if you recall me saying earlier, languages that use Hindley-Milner type systems can get away with essentially not annotating types. And that is also true of Gleam. We can basically remove our type annotations, and this code works equally the same. And the compiler and the LSP will perfectly infer that the type of client is client. It will infer that the request argument or parameter is of the get users request. And again, it does that by solving like these systems of equations and constraints on how we're using those variables or arguments in the code path.
How do you type those symbols, Dylan?
What was that?
The arrows and the triangle.
Oh, that's my ligatures. That's just the pipe operator. So it's like the I don't know what you call it, what you would use for or, and then just a greater than symbol.
Gotcha. Okay.
Yeah, it's just my font. I'm extra like that.
Is the use response then really a backwards arrow?
It is. It is.
That's not common. I don't feel like I've ever seen a backwards arrow in most languages.
Yeah, I admittedly, I think the only other place I've seen a backwards arrow like that is in OCaml, and I very seldomly use it. I use a backwards arrow like that when you use, you can have mutable data in OCaml, which is not a common feature in functional programming languages, but when you mark a record field as mutable to assign to it, you use a backwards arrow like that. But yeah, it's not a very common thing. But like I said, when you see that syntax in Gleam, you can think of it as something similar to using like await, and basically unboxing a value from another type, right? Like when we await a promise, we unbox the value inside the promise. You can also use the use keyword with results and options in Gleam. And in the case of a result, what it will do is it will unbox the OK variant or return from the scope with the error variant. Or if you use it with a option, it will unbox the sum variant if it has data, or immediately return from the scope with the none variant.
That's the question mark in Rust also, right?
Exactly. Yep.
Right.
I was getting ready to compare it to that. Exactly. And if you want to dive real into the weeds, what this is called a monadic bind, and has to do with monads, but super not important. So here's another example of some Gleam code. And here, this is modeling essentially what I believe is the WebSockets connection, or their WebSocket API. So we're going to model the possible messages we can get back from their WebSocket API. So we can get a notification, we can get a session welcome, we can get session keep alive, session reconnect, or revocation. And then like I generally want to be like logging these things to standard out or something similar. And we have to explicitly tell Gleam on how to convert our types to strings, right? Like it wouldn't make sense. Like how does it know what the string representation of like notification is? It's just like some nominal type. So we have this function called pub function message type to string. Takes the message type, returns a string, and then we can pattern match on that enum type. And for each of the branches or each of the possible variants, we can return a string. And again, omitting the types is equally as valid. I don't know if I said it on the last slide, but I generally like annotating my types specifically at like API surfaces, and I'll still like annotate them. I do a lot of type annotation because I think it's an easy way to quickly scan and get context. But specifically at like API surfaces that consumers might be using, it is well worthwhile to add types. So how would I describe Gleam? Gleam is a language with the simplicity of Go, the type system of OCaml, the concurrency model of Elixir, and the syntax of Rust, just without the hard parts. But that begs the question, does it meet the requirements of my ideal language? Well, let's find out. So I want a sound type system. And as we've kind of already covered, Gleam uses handling owner. So we definitely have a sound type system. Yep, talked about that. So let's look at what this, did I go too far? Yeah, so let's talk about what this means in practice. In languages with these kind of type systems, one thing you'll commonly find is that you have specific operators for operating on different numeric types. So you'll see here we have this plus dot, you'll see slash dot or star dot for working on floats or decimal values, right? And if you were to look at what the compiler were to infer the type of this function as, it would infer it as a function that takes a float as A, takes another float, and then returns a float. And it can figure that out because we're using that specific plus dot operator. If you tried to pass an integer into this, this would be, you would get a type error. Yep, and this is like if you turned on like hover docs or you did like shift K or turned on inlay hints in your LSP, you would see that this is what function type signatures look like in Gleam. Basically, it's saying, hey, this is a function that takes two floats, returns a float. And then if we were to add integers, right, we just use our normal plus. We use our normal slash or star. And this is going to be inferred as an int returns an int. And now if we look at this apply function, which is a little bit more interesting, it takes an x, a y, an apply function, and then we apply that apply function to x and y. So can anyone guess or tell me what this function is going to be inferred as? Bueller?
I'm guessing it's A comma B comma FN parentheses A comma B. Oh,
Close.
I guess maybe we need to have an output of C.
Yes. So the apply function is a function that's being inferred as a function that takes an A, some type B, and returns a type C. And if you were to plug this in here and kind of work backwards, you would find that this will be inferred as a function that takes an A, takes a type B, takes a function type, which takes a type A, takes a type B, returns a type C, and then ultimately returns the C.
Does this also mean that Gleam has an implicit return as the last statement like Rust does?
Yep, exactly. There is not early returns, and the last statement is an implicit return. Yep, that's correct. So if we were to look at the inference of these functions, right? If we were to fill this in, we should see that the compiler infers this as a float, a function that takes a float, and a float returns a float, and then returns a float, which is exactly what it does. And if you were to annotate A, which you can annotate variables like this, if we were to enforce, before we wrote out this function, that we need A to be a float and then call it this way, it would type check. And likewise, because of parametric polymorphism, we can call apply with a different function and we can pass it a different type, right? We can pass an int and have it inferred with the kind of same type signature just with ints. So yes, we have a sound type system. The next thing I want, as you may guess, is errors as values. So we already talked about the result type a little bit, and the result type is actually isomorphic with options, right? And what that means is like options are just kind of a constrained version of a result where the error variant is none. So the result type takes two different types as its type parameters, right? We get an OK and an error variant. And what that looks like in practice is, let's say we have this fetch data function and we're going to return a result that has some type data in it, right? Data is generic. And then we return some request error, which is we have defined somewhere else. And obviously, we're not going to fit the implementation here, but you can imagine what that might look like. So we're going to call fetch data and assign that to a variable data. And we're going to get a result type back, right? We're going to get exactly as our function was annotated. We're going to get a result that has some generic data and then a request error. But like, we can't really do anything with the result type. Like we can pass result types around. The result module has a couple of functions for, working with the result type, but like, how do we really get at the data that's returned? In Gleam, we have a couple options of handling that. The first is what we call an assert statement. This is probably your worst option, but we can assert that the result matches a pattern. So technically that OK data, assert OK data is a pattern match, just like you would use a match statement on. We're saying, hey, we want to match the result of this fetch data function with OK, and then we can unbox the data. We can pull the data from the OK variance constructor. And what assert is going to do is essentially say, like, if this return value does not match this pattern, we're going to panic and crash the program. This would be like using unwrap in Rust, right? Like if you unwrap a result and it's not the OK thing, it's going to cause a panic.
What is OK in this instance?
OK is the variant of the success variant of the result type. So results can have either an OK variant that carries an OK piece of data, some generic, right? That could be OK, it could be a number, it could be a string, it could be a user type. And you can basically pull data from these variants or constructors. So we're essentially saying on that side, we want to assert that we're getting the OK variant of result back from fetch data. Does that make sense?
Yep, and that's a built-in type, the result, or is that?
Yep, results are built in. Okay, so the next way we can deal with result types is using pattern matching. So we can assign the result of fetch data to fetch result, and then we can pattern match on that. And we know that, and the compiler will complain here if we don't handle all the variants, but so we'll match on fetch result. And because it's a result, it has two variants. It has the OK variant and it has the error variant. And if we match at runtime on the OK, we can pull the data out of that constructor or that variant, and we can process it or do whatever we need with the data. However, if we get an error, we can then pull the data from the error constructor, which in our case here will be a request error, and we can handle the error however we need to. So next, we can use the unwrap function on the result type. And the unwrap is different from Rust's result type, where if we unwrap a result and it's the error variant, rather than panicking, you have to give a second argument to unwrap, which will be a default value. So this is basically saying, give me the data from the fetch result if it's okay, or give me boom as a string if it's the error variant. And then we've talked about the use keyword already. We can use used unbox an OK value or immediately return from the scope with the error value. So Gleam has errors as values using a result type. And obviously, given that the result type is a sum type, and we saw pattern matching on getting the OK and error values out of it, it also has sum types and pattern matching, but let's explore this a little bit more. And we'll do that by implementing our favorite game, rock, paper, scissors. So how will we model rock, paper, scissors in Gleam and Gleam's type system? Well, we can model our move as being rock, paper, scissors. We can model our game result as 3 different outcomes, right? We can say player 1 wins, and we can put some data in there that like we can track what move player 1 threw and what move they beat by player 2. Likewise, we can do player 2 wins, again, track the same data, or we can have a draw where both players threw the same move. We can easily convert our moves to strings. Likewise for the game result. Now this is pretty verbose because I had to fit it on one slide. So I had to use string concatenation and kind of format it like this. But if you focus on here, if we want to match on the result of a game, we can pass the result to this function, and then we can pattern match on it. And we can say, if player 1 wins, let's pull out the move that they threw and the move that player 2 threw that they beat. And then we can print a string that says player 1 won by throwing. We can convert our move to a string, concat that with against, and then convert the player 2 move to a string as well. Same thing with player 2 wins. And then if it's a draw, we can pull out the move from the draw variant and essentially log out to standard out or wherever that it was a draw and the move that both players threw. Now, what does the actual game look like? Well, let's go line by line here. So we pass in player 1's move and we pass in player 2's move. And then something cool with pattern matching in Gleam is like you can match on pretty much any value. You can match on arrays and destructure them. You can match on multiple variables. You can match on record types. It doesn't matter. So in this case, we're going to match on player 1's move and player 2's move. And then you'll see kind of here that we'll use a comma to separate the two things or the two values, right? So the first arm we're going to look at is we want to match on the case where player 1 threw rock and player 2 threw scissors. In that case, we're going to return player 1 wins, and we're just going to pass in player 1's move and player 2's move. And another cool thing similar to Rust is like everything in Gleam is an expression. So that means that I can assign the result of a pattern match to a variable. And something else interesting about Gleam is that it doesn't have if statements. It actually uses pattern matching for if statements. So rather than saying like if variable else, else if or else, you'll just do case your Boolean value, and then you'll match on true or you'll match on false, which I think is like a really cool feature, and it limits the syntax and it makes the language simpler. And when you get to it, like you'll feel, I don't know, to me, it feels a lot better writing these succinct pattern matches on Booleans than you get these giant explosions of if then else's. Like imagine modeling rock, paper, scissors and all these different cases with if then else's. Like I know this code is dense, but like here you can see at a quick cursory glance, like declaratively all the states your program can be in rather than trying to parse like a bunch of nested if then else statements. So going forward, we kind of just walk down through all the different cases, right? Rock beats scissors, paper beats rock. I said that backwards, I think, but you get what I'm saying here, right? If player 1 threw rock, player 2 threw paper, player 2 wins. The opposite case, if someone throws paper and scissors, scissors and rock, scissors and paper. And then we have kind of these underscores, which are kind of like wildcard matches, or will match on all remaining cases. So we know that after we've handled those top 6 cases, right, that anything else is a draw. And we can just pass in player 1 move because it's going to be the same as player 2. Then we can take that game result, we can convert it to a string and just print it to standard out. So we have some types in pattern matching, but what about first class concurrency? Well, since Gleam, one of the compilation targets of Gleam is the Beam, we get OTP, which is the Open Telecom Platform, essentially out of the box for free. So what does that look like in practice? Well, let's look at this code here. So we're going to have this variable tasks, which is assigned to the list module. We're going to basically create a list, ranging from 1 to 100,000. And then we're going to map over that. So for each item, we're going to spin off an asynchronous task where we'll just print task into string completed to standard out. And then we'll return that integer value, which will be the numeric value or the integer 1 to 100,000. And these will all get launched off as those green threads or processes that we talked about, and they'll all be going concurrently. Then we'll, well, I got ahead of myself here, but you'll see this async keyword that essentially is telling the runtime to say, hey, we're going to spin off some green thread here or some asynchronous task. And then down here, we're going to take our results, which is assigned to the variable task, and we're just going to wait until all of them have resolved and then assign that to results. And if you were to look at what the type of results were to be inferred by the compiler, you would see that we have a list of integers. So once all of those async tasks that are running concurrently resolve, we can print out all tasks completed. We can take results. We can pipe it to int.sum, which the int module has a sum function, which can take a list of integers and sum them up. And then we'll take that sum and we'll convert it to a string to print the standard out. Then to talk about the actor model a little bit more, if you're familiar with Elixir, Elixir has this concept of gen servers. And what a gen server is, it actually stands for generic server, but it's like the core primitive of, one of the core primitives of Elixir's concurrency model. And a gen server essentially is like this async task that just kind of runs forever, or process that runs forever, and it holds some state. And then it also declares effectively like a handle message function. And that handle message function accept messages, and it's basically a loop that just runs forever. It serially processes every message that comes in. So in our case, since Elixir is dynamically typed, OTP is going to look a little bit differently in Gleam. Here, we're going to type our state. Let's say we just have a simple actor that has some state that has a count. We keep track of a count of something, and that count holds an integer value. Then we have the possible messages that can be sent to our actor. We can receive a increment message. We can receive a get count message, which that constructor has this reply with field, which is a subject, which holds a result that will either contain a state, which is our count, or it will contain nil. So what a subject is if you're familiar with Elixir or Erlang, they have this concept of PIDs. And PIDs are basically identifiers for other asynchronous or concurrently running processes. And you can communicate with that process via its PID. A subject is just a PID with a type. So here we're saying, hey, we're going to reply to some other process with this type. I like to think about PIDs and subjects as mailboxes, right? Like pretend subject just says mailbox. And like I've even in my Gleam code, I've aliased subject to mailbox. But you can imagine like some other process sends a get count message to our actor with reply with, and they put their mailbox in there. So our actor has access to some other process's mailbox, and we can stick a value in that mailbox, and that process can basically watch that mailbox and pull values from it. And then what our get count function looks like in our actor. So when we receive a get count message, we're going to get a copy of our state. We're going to pattern match on it to effectively, they've actually introduced syntax now that you don't need to pattern match on this case. I think you could just do like state.count and get the value out. That came out like a month or two ago, but regardless, that we pattern match on state, and we'll pull out the one variant which we have, which is count, and then we'll pull out the integer value and return that. So our handler, this is what I talked about, like this handle function in our actor is basically running on an infinite loop, processing messages serially forever. We're going to have this function signature that takes a message and state, so the current message we're processing and our current state, and we're going to return a type called actor.next that contains our message and the next state. So here, if you recall, oh, forgot the slide. This is what I get for not being able to rehearse beforehand. So what does the actor.next type look like? Well, under the covers, this is a type that is generic over some message, generic over some state type, and has two variants. As a continue, which holds our next state after we get done processing the message. And then we have the selector field, which is an option. Not super important here. It's not used all that often, but what the selector is, it kind of lets you change the implementation of the actor on how it processes messages at runtime. Kind of more of an advanced feature, but feel free to read the docs if you want to look at that. I don't think I've actually ever used that. And then the second variant is stop. And then that takes a exit reason, which is another type. So if we step through this, remember we defined our message type on the last slide where we have 3 variants. We have an increment variant, we have a get count variant, and a shutdown variant. If we get the increment, we're going to call actor.continue, and we're going to pass our next state as a count variant. We're going to get our current count from the state and just add 1 to it. And if you recall the continue variant from the last slide, right? Continue takes a state and a selector or an optional selector. Here, we're going to return a continue that just has our count.
Why don't we have to provide the option? Why don't we have to explicitly say none?
So under the covers, continue as a function, and the implementation under that will basically provide a none value for us if we don't pass it. It's kind of like in JavaScript or TypeScript where you can assign default values to parameters and omit them from the call argument. Basically the same feature.
Okay, they made it an optional parameter.
Yep.
That's very common.
Yep.
Okay, yeah.
Yep, you can use option. You can, like, if you write a function, like let's say we have like a function, let's just say add. We have pub func add. It takes an int or a, which is an int, b and an int, and then c, which is an option of an int. We could effectively do the same thing we do in TypeScript. So then the next message we have is get count, right? This is like when some other process wants to retrieve the current count of our actor. And here I even named that subject that's getting passed in mailbox. So we get our mailbox, right? And we're going to send to that mailbox a OK variant or a result, in this case, an OK value with our current state, which is the count. And then we're just going to return our continue so we can continue processing. And the last one is shutting down. And if you recall a couple slides back, let me see if I can get there. I could have stopped there, but the exit reason type, we look here, one of the exit reason variants is normal. So that just indicates that this is a normal reason to shut down. It's not unexpected. Kind of like Go. I think Go has ways to catch panics. But this actually ties into what I was saying about supervision hierarchies, right? So if like some child process died, and we could basically pattern match on the reason it died. And like if it's processed at normal, we can just choose to do nothing. If it's, you know, like some sort of defect or an unexpected exception, we can choose to restart it. We could keep track of how many times we restarted. So that's kind of how that works. So if we put this all together, let's say we have this main function, right? This is the entry point to our application. We're going to start up our actor on this line, right? So we're going to say actor.start. We're going to give it initial state, and we're going to pass it our message handler function. And what this will do behind the scenes is it's going to spin off a green thread or a process that sits and runs concurrently to the rest of our program forever and just sits and listens for messages. And here I'm using the assert keyword because like if it doesn't spin up, like I want to crash the process, like there is like no recovering from that. So in this case, using assert is good. So when you start an actor, you'll get its subject back or its mailbox back. And then we can use the actor module to send messages to our actor. So we can say actor.send, give it our process's mailbox or subject or PID, whatever you want to call it. And we want to pass an increment. We'll do that twice. And then if we were to use actor.call, which means we expect some state back from our actor. So we can use actor.call rather than actor.send. So we'll do actor.call. We'll do it. We'll send the message again to our process that's sitting in the background running concurrently. We're going to give it the get count message. And then we're basically going to say, hey, you need to respond to me in 1,000 milliseconds or we're going to error. So we get a OK value back here, and the count's going to be 2. We can then repeat this process, right? We could send another increment, get another get count, and you would see that we have 3, and then we can gracefully shut down. And you can kind of like extrapolate this out, right? Like when you start up, maybe you want to spin off an HTTP server, or you want to spin up a actor that handles in-memory caching rather than bringing in Redis, or you want to maybe spin up an HTTP server and a WebSocket server. Like it's so cheap and easy to do in Gleam and even like Elixir with this model. So we get first class concurrency. What about DX as a core value? Right, I don't want to think. I want programming to be enjoyable, simple. I want being able to do the right thing, to be obvious. I want to be able to get big docs. I just want to have programming be a pleasant experience and guide me to doing the right thing and building quality, stable software. So Louis and the core team are incredibly diligent and thoughtful about keeping the language simple, small, and practical. Much like Go, you'll often find that there is one way of doing something and the language will naturally guide you there. If you were to go into the Gleam Discord, and I was admittedly one of these people at first, like I wanted, coming from OCaml and Rust, like I wanted a macro system. I wanted, you know, a whole series of other features that weren't in the language. And I was like, oh, why doesn't this have this? And then, you know, over time, I grew to appreciate the simplicity and found that the tooling that the LSP, which I'll talk about here in a minute, that provides you, they don't need to add all that bloat to the language. I mean, we even talked about like, there's not even if statements, right? To handle Booleans, you pattern match on it and handle the true and false variants. And one thing I don't know if I mentioned it earlier, but like, I think languages like Gleam and OCaml, F#, languages that use handling known, or even Rust to some degree, they guide you to implementing the simplest abstraction possible first. They make it easy to do that. So you're naturally going to do the easy thing first before you try to do something complex. And in the case of these type systems, that's modeling your programs in a much simpler and lightweight way. New features and syntax must meet a very high bar and strictly improve the language while maintaining its simplicity. I should mention about the LSP, right? The LSP in Gleam over the past year has gone from a functioning LSP, still better than a lot of languages. But you know, if you're used to working in like TypeScript or Rust that have really, really good LSPs, it was like, this is kind of not as great as I would have hoped. To today, Gleam's LSP might be the most featureful and pleasant LSP to work with. The team, since the 1.0 release, has put a huge emphasis on making the LSP good. And some things, and they do this as a means of keeping the language simple, right? So rather than adding like macros to the language for like deriving JSON serializers and deserializers, they have a code action in the LSP where you could just like, you know, if you're in NeoVim or whatever your command is, you know, I don't know VS Code shortcuts anymore, but right click on a type and, you know, generate, you know, JSON deserializer, and it'll generate that code for you. Just like features like that built into the LSP rather than the language, like they really, really have an eye for keeping the language simple, easy to onboard to, low mental overhead, yet having all the features you would expect from a language just kind of delivered through tooling rather than the core language itself.
Dillon, just in case people aren't familiar with what an LSP is, do you want to do a small blurb on what it actually is?
Oh, yeah, sure. So LSP is a language server protocol. It was, I believe, made by Microsoft. So like when you're in your code editor, if you hover a type and you get the little dialog that tells you, you know, what the type definition is, or if you want to go to definition or go to implementation, or, you know, like if you're working in TypeScript and you have like ESLint or Prettier or Biome, you get like the options to like format code or fix lint errors. Like that's all driven under the scenes by the LSP. The LSP is basically like using the language's compiler under the scenes to like look at your code and assist you in writing code. It's like what will help you, like when you type, it's what gives you auto completion too. I don't know why I didn't think of that as the first example. So like when you're writing code and you get the little pop-up with the various either fields on a type or functions that you can call, like that's all driven by the LSP looking and analyzing your code under the covers. So Gleam's like leaning on the LSP to make the development experience really, really top-notch and really, really good, especially when it comes to things like code generation. So modern tooling. Gleam has a single binary that does everything, and I love it, and it's nice, and I wish we had this in TypeScript, which I work in every day, but we do not. Basically, you're one-stop shop for everything. You can add dependencies, you can build a project, you can type check, you can clean build artifacts, you can search dependencies, you can generate docs, you can format your code, get help, like it's all just right there. You can publish to hex, you can get into an interactive shell. It's just so nice when a language has this. Like Cargo with Rust is another great example that does this well. Like just having one tool that has good man pages or documentation built in, and like it's almost guessable. Like you can almost guess the command that you want with Gleam, and it just works. And like if I did like Gleam install, it's gonna be like, hey, I think you meant Gleam add, right? It's just so friendly and thinks about all the like sharp edges that other tools have. Like I said, they have stellar documentation built on top of hex docs. So this is an example of Gleam's standard library, the docs for the result type. And I should mention here too that I think Gleam is without a doubt the best introduction to functional programming you can get, because there's not a single mention of a monad anywhere. There's nothing about functors. There's nothing, just none of that jargon is there. It's just straight to the point in learning how to use these things in a practical way. Like if you go into the docs of Haskell or Result or OCaml or Rust, like trying to learn about the result type, you're gonna run into words like bind or flat mapping, like all these things that are important, but aren't important to getting started and learning. And like in these docs, like they just do such a good job at introducing these concepts and learning how to use the language and do functional programming, that there's just, I don't know, there's no better way to build your muscles and learn it than Gleam, in my opinion. And much like Rust and Elm, they have really, really good error messages. This is kind of what I was talking about before with Elm, like where it's going to point out the error, exactly where it happened, what you did wrong, give context, and then almost in all instances suggest a way to fix it or link to the docs. So yeah, just all around. And these continue to get better every single release. Like even from the time that I did this presentation, which the version of Gleam was 1.4, they just released a release candidate for 1.7. Every release has gotten better error message, better LSP tooling, better context. So I'm really bullish on where they're going. So obviously DX is a core value for Gleam. And the last thing is, can I write it once and run it anywhere? Well, we know that Gleam has 2 compilation targets. And we basically get every runtime environment. For long-running processes and servers, we're going to generally want to use the Erlang virtual machine or Beam. If we want to run Gleam in the browser, we're going to compile to JavaScript. In Edge and serverless environments, we're going to also compile to JavaScript. For CLI and dev tooling, we can use either or. This is one place where I wish Gleam was a little bit better. I wish Gleam had a native target, but in either case, we have the decision between either runtime. Where did I get to here? I would say that I've heard it talked about quite a bit now, and I'm not sure if the core team has this on the roadmap yet or if any of the contributors are looking into it, but I know there has been chatter about essentially adding an LLVM backend, which is like the backend to the Rust compiler. LLVM is like, it's made by a guy named Chris Latner. He made Swift. He's working on a language called Mojo now. A lot of programming language compilers use LLVM behind the scenes as like a compiler ecosystem. So I'm hoping at some point in the future, Gleam gets a 3rd compilation target being basically native binaries. If that had that, like Gleam would literally be perfect. But needless to say, we have the choice there. And it's also kind of like TypeScript plus, right? Like we get a sound type system. We can easily bind to any JavaScript and TypeScript library on NPM or code you write next to Gleam code. Super easy. The API for binding to JavaScript is dead simple. You can generate TypeScript types from your Gleam code, and it compiles the ES modules. So you can, in your current TypeScript application just today, you could add some Gleam code or a Gleam package, and you could compile that to TypeScript or to JavaScript with TypeScript types, and then call that code from your existing code base. So we basically get all the benefits of the JavaScript and TypeScript ecosystem just without all the pain. So we can write it once, and we can pretty much run it in any environment. So is Gleam perfect? Kind of got ahead of myself here a minute or so ago. It's not perfect, right? Like some things are painful with the language, like doing JSON serialization, deserialization. But like even since I wrote this slide, you can now get by that with code generation with the LSP, right? And like finally, like I said, the thing that would genuinely make Gleam a perfect language to me would be having that native compilation target. So it's not perfect, but it is ideal for me and hopefully for you. that is the talk. Thank you. Thank you for listening and having me. I appreciate it deeply. This talk is like one of my favorites to give because it's like a culmination of my career up until this point and the things I found valuable and interesting. And yeah, and also if you enjoyed this talk, you should go to RVA.JS because I will be speaking there, but not on Gleam. I will be talking about Effect TS. So questions, comments, concerns, complaints?
Yeah, I have a. I'm sorry, I don't want to jump in if somebody else has a question, but I have a question. I was kind of curious. So you obviously have a lot of experience with a lot of different programming languages. Did you at any point in time pick up like a theory of programming languages book, or is it just from your CS education, or just all the experience with all the different languages that you have?
That is a great question. I have not. I do not have, like I kind of mentioned earlier, I don't have a strong academic background at all, and especially not in PL theory. I would love to have the free time to dive into PL theory. Like, it is definitely an interest of mine now, and I try to read white papers that I can consume or blog posts. And like, there's a bunch of blog posts that have been like super influential on me in this space. But yeah, it's mostly been through real world just practice and application of this stuff.
Gleam seems really cool, but there was one thing I had was you didn't talk about the performance at all. Do you know how the performance is on Gleam versus, like, I assume it's slower than Rust because it's garbage collected, but you know, how does it measure against like Go or C# or Java?
I would say it competes in the same ballpark. You can probably squeeze more performance out of Go than you could Gleam, right? Like under the covers Gleam, right? You have your two runtimes, right? You have either Erlang or you have JavaScript. So you're kind of constrained to the performance characteristics of either those two languages. You're generally probably going to get better performance out of JavaScript compiled code from Gleam, just because the compiler is really smart and can optimize that process for you. And it's really hard to write good TypeScript, performant TypeScript, coming from someone that's my core proficiency, and been doing it since I was 13. So you'll probably generally get better performance out of the JavaScript target with Gleam. And then Erlang was built to power the phone systems across the world. It does some incredible things. Fly.io is built on Erlang, Elixir, and Gleam. So you wouldn't be using Gleam, at least until it has a native compilation target, for really CPU intensive or bound work. It's really going to shine in IO bound work.
That makes sense. The concurrency earlier with the actors, if you wanted to have multiple, could you have just looped and created a bunch of actors? Is that how you would do that?
Yep, exactly. You can. I was using the task module earlier for spinning off that list of 100,000 things, but I could have just as easily spun up 100,000 actors maintaining count states.
And then you need some way to obviously distribute the messages to them, etc. But
yep, exactly. You would each actor you spin up, you get that subject,
right, the mailbox back,
whatever, and you would have a way of, whether that's a hash map or whatever you want to do to manage this. Yeah, exactly. Okay. It like you could making a load balancer in Erlang would be so stupid easy. Like it really is a beautiful system for creating, or language for creating distributed systems. Like that is really, I think Erlang, like even before I ever learned about Gleam, like I had the opinion, you can go back on my Twitter timeline and like I have tweets saying people are sleeping on Erlang. I think Erlang is, a painful language to write, but I think the properties of Beam are amazing and like are one of the like OTPs, like technically one of the coolest pieces of software I think that's ever been made.
Cool, thank you.
Sean, I saw your hand go up. Let me pull up the message here. I'm sorry. Did you have a question?
We can't hear you if you're talking.
Sorry about that. I had my lid closed. Can you hear me now?
Yes.
Yes. Okay. So I'm definitely less familiar with all the functional programming languages. A little bit more so on the Java side. So when you did mention that you had worked with Java in the past, I was like, okay. By the way, props to Northern Virginia, DC area developers. I remember seeing your name a lot in the DC tech chat.
I was very active in there a couple years ago.
So if if Gleam is like the accelerator for Erlang and and Go and high concurrency programming languages, would you at all compare Gleam to Elixir and Go and JavaScript to when Scala first arrived for Java?
That's an interesting question. Yeah, you could almost compare it, like two good comparisons might be like Scala coming to the JVM, right? And also ReasonML, which if anyone's not familiar, ReasonML is just an alternative syntax for OCaml that looks kind of more like JavaScript. It's kind of similar, but the thing I think that Gleam has the benefit of standing on the shoulders of giants. It learned from the mistakes of Scala and ReasonML. And also, I'm at least of the opinion that I would rather build a distributed system or IO-bound work on top of Erlang's virtual machine than the JVM. So it's not trying to be this, pure, I mean, it is a pure functional programming, but like Scala still has like those traits and elements that you find from languages like Haskell and OCaml. And like, I would love to write, I personally would enjoy writing Scala. Like if I had to work in the JVM, although Java's gotten pretty good over the years, like the Fiber or Loom, Project Loom, right? I don't know if that's merged into the core runtime yet, but like Loom, you got green threads. There might be, I think, something close to pattern matching now and like result types and stuff. Like Java is like caught up, and that goes back to like one of my first slides, right? Like these older languages are starting to adopt these features. But I think Gleam has the benefit of learning from the mistakes of these languages and picking the pieces that have worked well for them, and just having a more cohesive story, or like a unified story, the tooling, the docs, like all of it just goes together in making this really, really pleasant experience for authoring software. And then coupling that with great runtime options. I think it's an easier sell for a team to adopt Gleam than something like Scala, because Scala has a ton of syntax and foreign ideas, and Gleam is just simple and it can integrate into most stacks and projects already.
Thank you. I do have a tag-on question. I did go to the Gleam docs website. While I do see that there are lots of contributors, they don't really have any, excuse me, they don't really have any companies that have really sponsored or adopted Gleam. Would you be able to share any of those, or
Yeah. So the title sponsor for Gleam for quite a few years was Fly.io, and Fly is using Gleam under the covers to power a handful of their services. So Fly is a competitor to Vercel, widely used. I love using Fly to deploy projects too. And I think that's a testament to it. And then also I would say Gleam is very young from a language perspective, especially even compared to Elixir, which is relatively young. Its 1.0 was only a year ago. And I would have not recommended anybody deploy Gleam to production pre 1.0. But if you were to hop in their Discord, you would see a growing cohort of startups and companies starting to use this in places. I really wish these companies using it would sponsor them more, because Louis, the creator, does it full time. And like I said, the velocity and quality at which these 3 or 4 members of this core team ship quality features to this language is unbelievable. They rival the speed at which and quality that the TypeScript team delivers stuff. So yeah, I wish there was more sponsorship there and more companies putting their name on it, because there are companies out there using it. But again, it's been not even a year since the 1.0. So there's a couple of people within Vercel, specifically within our edge compute teams, that have kind of been eyeing up Gleam, Elixir versus Go for some net new services, and it'd be cool to see us use Gleam.
So the big one you said was Fly.io.
Yep.
So does that mean that Gleam is and you did also mention how it would be good for using on the edge. So do you see it all is Gleam something that could be used in products like Jenkins or GitLab or GitHub even to connect cloud resources?
What I might ask for clarification on what you mean by connecting cloud resources, but like off the top of my head, building like a CI/CD system with Gleam, like that's a great use case for the language. Like think about scaling out like GitHub Actions, right? Like super concurrent across multi-tenant, like millions of processes going, like that is a really good use case. And like one of the cool things about the Erlang virtual machine is like you can basically replace Kubernetes with it. Like you get like caching, you get the database, you get like all these things for free from the runtime. And the runtime scales and can handle sharding and load distributing without you really having to tune anything or think about it. Like if you have an actor that handles some messages and it's in a cluster, like it will load balance that to all the actors and maintain the PIDs to the right place. Like that's been in like Erlang since like the 70s.
Thank you.
Yep.
So earlier you had that example of the async task, and then you called a function to await it. Does that mean that things like await and async and promises and tasks in the C# lingo, they're not language constructs? They're simply handled by functions in the standard library? They
are. Like the core primitive under the cover is, I want to say they're called processes in the Erlang VM. There's just a package to make working with them easier. And in fact, that might have even got merged into the standard library. I'm not sure. You'll have like Gleam/OTP will be the library you add, and then you'll get like all the OTP abstractions. But you can do all of that stuff manually without the abstractions using the concurrency primitives in the standard library.
Okay,
I think it's like Gleam/Erlang is like the module you would use.
Well, I wasn't even thinking of like the actors. Maybe I'm not as familiar with Erlang and whatnot. I just meant that, for example, both JavaScript and C# have the await as a language construct where it does alter control flow and unwraps the promise or the task. Whereas in this case, you were passing it to a function, and that's why I was like, that's a little different.
It can be blocking if you want it to be, or it cannot be non-blocking if you don't want it to be either.
Okay.
That's built into the runtime. Yeah. Sorry.
Okay.
And like what's cool is the compiler also knows like if you're compiling to JavaScript, it needs to use promises, and if you need to write Erlang, it'll use like the Erlang VM processes, and you can even get in this paradigm of compiling the same thing to two different runtimes and doing stuff like that.
All right, last pair real quick then. Mutable versus immutable. It looked like everything you were doing was immutable. Does it have mutable support?
Nope, no mutability. But I don't know if I mentioned it, like data structures are super optimized for cheap copies and persistence, or persistent data structures under the covers. What you would expect.
You can do all the calculations about to see if it actually needs to be immutable, or if under the hood you can just make it mutable. The last one was it didn't look like there were members or of any sort. None of the type I never saw you calling a function on a type.
That's a good call. Yes.
Yeah.
So Gleam is much like OCaml in that it has modules and it uses module style programming. In fact, Elixir does this too, where your core means of organizing code and abstractions are going to be modules. Generally, modules will be a single file, kind of like a ECMAScript file, like in TypeScript, right? Although we shove everything in the world in JavaScript files. And really what you'll commonly see is that a module will be one file, and it will expose functions, pure functions generally, or you can handle async stuff with the primitives. But modules are generally scoped to operating over one core type and maybe some supporting types. And like I copy this practice to TypeScript now. Like from having written in this style in OCaml and Gleam, like I now, when I start writing like a TypeScript file, like I'll declare at the top like the core type that I want this module to operate over. And then I'll just write a bunch of basically functions that operate over that type. And that is like the purpose of that module. So you're right in saying that there's like no sort of like class or attaching functions to objects. You can put a function on a record type as a field and do that.
Sure. Yeah.
Right.
Well, I was thinking like Haskell. I believe it's been a little bit, but I believe it also works a similar way with modules. And you can have there's data types and there's functions, and that's it. No data type ever has a function on it the way a class in C# or Java would.
Right.
But 2 weeks ago I wouldn't have known what this meant. But since I've been playing with Rust, I've been kind of learning to appreciate that it has the same module structure.
Yep,
It has functions that are separate from the data types, but you can still associate a function with one of the types, the implementation essentially. And I was curious if, because it looks like Gleam was inspired a lot by Rust, if they also copied that idea, or if
The syntax
they said, no, keep them completely separate.
Yep, no. Generally, you're going to find that you have your module, and you'll see, like, in a lot of cases, one of the things that tripped me up that I didn't love at first with like the syntax was that the modules are lowercase, so they kind of look like variables. I still wish they were uppercase. So I used saw if I was doing like int.sum, which takes a list of ints, I called int.sum, and if you were looking at code file higher up, there was an import for int as a module, and then I used that module down below. So yeah, functions are generally are attached to modules.
Okay, but so I couldn't ever be like, let foo is foo and then be like foo.bar to recall a function on foo. Well, okay, I technically could, because I could make it a record type and I could assign a function to it. I guess.
Yeah.
Okay. But that feels.
I would say that's not a super common pattern.
No.
OCaml people use that to get around what they call rank 2 polymorphism, which is like a programming language nerd thing.
Sure.
But Gleam has rank 2 polymorphism out of the box. Like that would be like, you saw the example where I used that apply function in the same scope I called it once with ints and once with floats. If you did that in OCaml without attaching a function to a record, it'd be like, nope, this function now only takes ints, and you're not going to be able to call it in the same scope with floats. Rank 2 polymorphism lets you basically reuse the same generic function over multiple types in the same scope. I think. Don't quote me on that, but like that's my loose understanding of that. Again, not a deep academic background here, but
sounds roughly right to me. Like I'm not super well versed in this stuff either, but I think that's right. Oh, thank you. It's really neat. I'm excited to try it out because I have a similar thing where I've seen all these different languages and tried to play with them, and I'm always like, oh, I love this part of it, but I don't like this part. I love this part, but I don't like that part. And I've never used Erlang, but I've heard that concurrency is the thing that it absolutely nails in a way no other language does. So
it's so true. Like there are systems in Vercel that would be so much better suited for running on the Beam than on TypeScript or Golang. Yeah. And one of our like principal engineers is a huge Beam person. He's the person that's like pushing for Beam stuff and some of our edge platform stuff. But there is a part of the Gleam website. If you were to go to tour.gleam.run, it's basically like an interactive code playground for like walking through the entire language. You can do it in under an hour and have a really good grasp on the minimal syntax and features in standard library. So highly recommend walking through that because it's actually really good.
Excellent. Thank you, Dillon, again for coming and showing off Gleam and all of its features, and not only Gleam, I guess, but getting us to just think about all the various different languages out there and the different aspects to all of them. So thank you so much.
Yeah, thank you for having me. This was great. I also like the conversation afterwards. Love that. Love geeking out about this stuff. So feel free to like hit me up anywhere you can find me. My DMs, I think, are open everywhere, and I will generally see them. So more than happy to continue conversation async.